All right. I am standing between you and lunch, so I should probably start. So there's the topic, there's the slides. We'll get into it. Um, so that's me. Here's a quick disclaimer. I'm from Chicago. I talk fast. So when I don't talk fast, it sounds sarcastic. I am not trying to be sarcastic, so just kind of a heads up. I'll try not to talk too fast, but I also don't want to sound sarcastic. So there's some stuff up there. Um, Wrote some books along the way. This is a beautiful conference. I love kind of the everything that's been going on. But look, you're not here for me. You're here for the rest of the stuff. So let's just kind of jump into it. I go into organizations because people say things like, "We used to be faster. We used to get a lot more stuff done, and now we're slow." And then somebody says, we're slow, and then we brought in Agile, and then Agile didn't make it faster. We just spend more time talking about tickets. And I see this pattern in a lot of organizations. This is a simple causal diagram. We got a lot of ideas, and as we get more ideas, we get more pressure to deliver. Turns out, as you increase your pressure to deliver, your stability starts to go down. Teams are doing more things, you have more ideas going on, it becomes harder to test, stability goes down. People don't care. They want to get out faster. When stability goes down, quality also goes down. When quality goes down, people want more work to get done and can have more ideas, and you get in this vicious loop. And people say, but we want to be faster. For me, it gets even worse. For some reason, in organizations that say we are going too slow, we can't get anything done, they say, we can't get anything done in a month. So let's plan on doing 5 things in 3 months. Or let's plan on doing 6 things in a year, because that will solve the problem. Now, what I think is interesting about this is fundamentally, if this is kind of like the vicious loop you're in, we can't get anything done, so we have more ideas. We have more ideas and we don't care about our architecture, so things get kind of mangled together more. And so then we have more ideas in flight, and then teams have more cognitive things to worry about, and then we wonder why nothing gets done. This is the introduction to why architecture matters. Fundamentally, when this comes down to it, it's an architecture problem. Now, what I'll tell you is this. I don't talk about that's a good architecture or that's a bad architecture, that's a good design or that's a bad design. I talk about if it's appropriate in the context of the problems we're trying to solve. You could have the worst design ever, but if it's easy for teams to get stuff done and it's making you money and your customers are happy, I don't care if it's a monolith. It's easy to work with. We can get stuff shipped. Cool. Let's do that. The techniques I'm going to show you, I'm going to also give you an example with an organization I was with that had this exact same problem. One team getting stuff done, wanted to get more stuff done. Let's make a second team. 2 teams getting less done. Let's get more teams. 4 teams, less stuff done. When I came in, they had 14 teams, shipping less than one team used to. The fundamental problem was the design was appropriate at a point in time, and it no longer was appropriate because of where the product needed to go. So those are the techniques we'll introduce. I'll tell you the story along the way. Fire away with questions. Techniques, outcomes, right? We'll talk about event storming, some strategic DDD, some C4 stuff. We'll talk about how this influences architecture and planning, but it's really about product context to help us make better decisions. I postulate this for you all. Behind every decision in your architecture is an assumption about your product. Nobody is, I hope not, nobody says we're going to do microservices because microservices are microservices. Ideally, it's to serve, well, maybe you do, I don't know. But ideally, it's to serve some kind of purpose because you want resiliency, because you want availability, and because like these parts are more important than those parts, right? So like you want to do it because the context of your product. And so like for me, I want to have context behind the decisions I'm making. Here's the dirty secret. You get architecture one way or another. Either you can be intentional about it or you just deal with it in 10 years. So I want to be a little more intentional. All right. The fun stuff, let's make sure we're on the same page. Everybody know this gentleman? Who knows this wonderful gentleman up here? Yeah, please somebody shout out his name. Ward Cunningham. If you didn't know, his name is actually right here in the slide, so it makes it a little bit easier. Yeah, I know, right? What do you know? Who knows Ward Cunningham? Well, not personally. Who knows about Ward Cunningham? What do you know about him? I'm sorry? Yes, Ward invented the wiki. Also, he invented something else. He invented a term that you probably all use to talk not about your code, but about your peers' code that you've inherited. Ward coined the term technical debt, right? Again, not your code, somebody else's code. What does technical debt mean to you? Anybody? What does technical debt mean besides the other person's code? What do you, hard to change. Yeah. What else? Hard to change is where, is where we're at. All right, cool. There's a video from Ward from a few years back where he talked about kind of what he meant. And the reason why I bring it up is I think it actually, it's just a nice way of him framing it. What Ward said was, when we're writing code, we are manifesting our understanding of the problem. We are saying this is how we understand our customers' needs, and this is how we understand how the product should work, and this is how we're going to create this model of what we are understanding. Now, what Ward said is, we know more once people use it than we did when we started. And he called that technical debt. He said the difference in the model of our understanding is different, and we need to rectify, we need to solve that gap. And he called that technical debt. I like that because I think that acknowledges the fact that we're going to learn as we go. And it's not just we took some shortcuts along the way, right? It wasn't just ChatGPT told us to do this. So please keep that in mind when we're thinking about these techniques, that we need to be evolving as we go. We know more tomorrow than we did today. And then this diagram is another kind of back context I want us to be thinking about. It's from the book Notes on the Synthesis of Form by a gentleman named Christopher Alexander. Christopher Alexander, friends? Christopher Alexander is the gentleman. He is a physical architect. He built physical buildings. He is a professor. This book is about physical buildings. He also, just for context, Christopher Alexander is the gentleman that created the idea of pattern languages, which of course then became into software around patterns. A funny part about Christopher Alexander, when he was creating pattern languages, he wanted to make it easy for architects to build spaces that felt alive, that gave you like purpose. When you walked into a place, you knew what it meant. I don't think we did that concept justice in software. I don't think anybody says, but that bridge pattern I really love. It makes me feel good. Anyway, what I love about Christopher Alexander was when he was talking about physical buildings, he would say context matters, and he would say there wasn't one obvious solution. And on top of that, various aspects of our decision were interdependent. If you're building a building, the way you go about how much it costs might affect how easy it is to build. How easy it is to build might affect the performance of the building. All of these things are interrelated, so we can't make decisions in isolation, which feels to me just like software. It feels to me like when we're making decisions in software, we can't just say all of these decisions are independent. The database we choose is independent from our patterns, is independent from our language, is independent from our deployment strategy. These are not independent decisions. And so we need to have a way of grouping our decisions to be able to reason about it. Why are we making these decisions in context? So for me, architecture then becomes about fit within context. Long way of saying, I want us to be able to use product context to get the architecture we want to have instead of the accidental architecture we deal with. All right. So I'm going to walk you through some of these techniques with the examples. Some of them are going to be hard to read intentionally because it turns out companies don't like you sharing information about them too much, right? So some of these will be a little bit hard to see. The story we're going to use again is this 1 team, 2 team, 4 team, 14 teams, nothing gets done. Teams are stepping on each other's toes all the time. So how do we go about solving this idea of like macro decisions? How do we go about figuring out with these 14 teams, what should they actually focus on? What should their core concepts, their core domains be? Looking in essence for in the DDD world, which is way more accepted evidently in Europe than in America. In America, people look like I'm crazy. We started doing some event storming to look for simple domains for teams to own, bounded context, those types of situations. In general, what we were looking for was, from a product perspective, how do we map product intent to teams, and so we could understand where we wanted to grow the product intentionally. Where were our market differentiators? How do we orient teams appropriately to solve these problems? We did this together, and when I say we did this together, it was architects along with product owners coming together, doing event storming to talk about the context of the product, not the systems, the context of the product, so we could understand how the product needed to work, and then we could talk about how we wanted the teams to work. Because if we didn't understand the way the product worked, then the teams are always battling the product. That's what we did. Any questions? All right. So this is by no means the end result. This is a subset of it. And again, it was 14 teams, and we're trying to figure out what should teams own contextually from a product. Now, for context, I'll tell you this, it's a financial organization, and so we can start seeing when the meaning of the product starts to change. This is the outcome. How do we get there? Everybody's in a room, product people, architects, everybody's in a room together, and we say, tell us the important events in the life cycle of the product. Now, of course, I will tell you this, just for context, we did have to assume that there was alignment on what our product was, right? So there are some basic assumptions here. If you need to do Wordley mappings to understand kind of like what your differentiators are, those are good things to have done. In this company, the fundamental idea was we want your money, right? If you give us your money, we promise you we'll give you more money later. Right, like that's kind of like how it's supposed to work in this company. And so we said, walk us through the events from the life cycle of the product, from how we go about people engaging with us until they stop engaging with us. Everybody's in a room, they're putting up stickies because that solves all problems, and they're writing it down, coming up with the events, putting them sequentially. A lot more events than this, but at least contextually you can kind of see where they're at. There's a prospect gets created, they get assigned to an agent, they get an account created, the bank information gets created, and so we get the money, we trade, so on and so forth. From there, and this is where it got really interesting, the first question we asked is, when does the meaning of the account change? Right? Now, in the DDD space, you have ubiquitous language, kind of what does this mean in our world? This is what was interesting is the account meant something different when they were just a prospect. We don't have their money. They haven't signed any documents, so there are only certain things we can do, and there's certain things we can't do. Right? We can only market to them. We can't ask them for their spouse's names, right? We can't get the bank information. But the context meant something very particular there. Now, as soon as a significant event happened with that black vertical line, when the account meant something different, they're no longer a prospect and they're a client because they created an account with us. Now the context meant something different. They do some different things. Eventually, we get their money. As soon as we get their money, now not only are they a client, they're a client that can trade, and the account has a different meaning. And so you can see how this pattern plays out. Now, in the code base, it didn't look like this at all. In the code base, it was a whole bunch of case statements and if statements because when this was one team in one model, it was fine. But as soon as you go to 14 teams and they're all having to share the different contexts at the same time, you have a problem. So we laid this out and we talked about kind of like where are these boundaries where the context means something different. There was two ways we could see this. Anybody want to guess the two ways? Two ways were, one is there's a lot of sticky notes in certain areas. Because these people, the product owners and the architects, these are the things they're all thinking. We got their money, we got their money, we got their money. Yeah, so that's obviously important. The other thing that happened was, because this is how you design systems, was somebody said, well, in the database, we have a status column. And the status column changes from N to O to C to P to Q, and they had like 15 statuses. So they're already dealing with this problem of context shifting by creating data problems. And now every team that had to worry about writing code had to check the status for all their code. So the code became unwieldy. So if you're asking yourself, why are we going slower? It's because you're managing too many contexts. So this is how we started. We got to events, kind of broke it out. From there, we took a step backwards and we said, what are the commands and the blue sticky notes to the left that cause the events to fire? We're trying to add fidelity, right? Because some things can happen in parallel, some things happen asynchronously, some things happen synchronously. We kind of added some more fidelity. The black sticky notes boxes on the right were for external systems. And we're trying to create this bigger, better visualization from a product perspective as the product's changing. What are the commands happening? What are the significant events happening? When does context change? The goal being to find, again, team boundaries. From there, we took our first best guess at what these boundaries might look like. Now, this is, again, not everything, right? There was 14 teams. We ended up with the first pass with 10 kind of contexts and what we thought 10 teams could own. The first question I was asked was, there aren't enough bubbles. What do we do with the other teams? Not my problem, right? Right? And I'm not trying to say hard. I'm not trying to be mean about it, but it's, in essence, you grew to this complexity of 14 teams because you couldn't solve the context problem. If we want to solve the context problem and get it to we can shift better, this is the model we need to move towards. So we created this, some kind of boundaries of teams, and I'll come back to this later on to talk about how it impacts the teams. But what's the interesting idea here was finding boundaries for context for teams to own so they could know state. As soon as we did this, the code was fixed. No, I'm kidding, right? That never happens. Nobody puts sticky notes in a whiteboard and the code is fixed. You actually have to do work, right? So this is, if anything, this is the strategy. Where do we want to be? How do we more closely align this kind of macro level boundaries of teams with the product? Now, what was nice about this also was, from a product perspective, and we saw this decoupling of areas, we could talk about what are the areas that for product growth that we want to invest in, and what are commodity areas. Opening an account and managing contacts isn't that interesting. We could, if we wanted to, we could buy that as a product. But the way we go about doing the onboarding and the trading, that was our secret sauce. So we wanted to make sure we had expertise there. So now we can talk about where we want to grow at. We could talk about, if we're trying to go international, where does international affect these teams? In what context? It doesn't affect all the teams, it affects certain areas. So now the product can make better decisions. It started from this idea of laying it out and finding better boundaries. From Eric Evans in the DDD space, look, we came up with an idea. We used a scenario, right, to map it out, to find boundaries. We had to actually write code, right? We had an idea. We had to get with teams, write little bits of code, kind of probe the system. What happens if we change this? What are we missing? What other ideas are not there yet? Use that as a feedback into our model. Use that to feedback into this to see what changes. After we did that, that took about, I think, like another 2 months. Then we would look at a new scenario, and we would say, based upon a new scenario, does that change any of our models? So not only did we get together to model out the intentional architecture, we would then do little code probes to see what we missed and what might be different. And then we would come into new scenarios and say, does the model need to be updated? As we continuously refactored and moved towards a better architecture. If you go about doing this, of course, the technique being event storming, capturing events and significant events, right? Talking about context changing, looking for boundaries of teams. Having done this, of course, with that organization, with enough other organizations, at least in America, what happens is people want to inventory systems. They're less interested, at least initially, and maybe it's just the architects, they were less interested in trying to figure out the product and the product flow, and they wanted to talk about the systems. Where does this mainframe job fit? What about that report? And they're more concerned about the aspects of the stuff that's been built than the context of it's being used. And so continuously pulling it back to the product. The other thing that I would tell you is, having done this, I've seen a lot of duplication of work, an immense duplication of work, because the product grew in different directions of the architecture. And so to solve that, People were building tools in multiple different contexts over and over again to solve the same problem. So by modeling it out, eventually we'd get to some systems and we'd talk about these 5 things do the same thing, just in slightly different meanings. Which one is the right one? And so we would actually start reducing software. You can do that too. It's a nice way of getting there. And of course, the idea of ubiquitous language as signal. I'll give you a quick story and then we'll get to some more of the fun stuff here. Working with the first team, so we drew out the bubbles to solve all world problems. And we get with the first team. The first team has a bug to fix. And the bug, as stated to the team, was when the network is over 260 items, it crashes. Pretty descriptive, right? Over 260 problems. What do you think that meant? What do you think it meant if the network was over 260, there was problems? It's close to lunch, so I'll give you the answer. All right. I got 3 different answers from the team. One person on the team said, well, obviously, if we get more than 260 requests in a second, something has to lock up. Okay. And then somebody else said, well, network actually means, if you're a client, it means all the people kind of in your circle. So like your spouses, your kids, anybody that could sign for you. And so if there's over 260 people you're related to, which is a lot, that becomes a problem. Okay. And then somebody goes, but there's another problem. They said if you're an employer and you have more than 260 employees, that's a problem. So right there is an example of using ubiquitous language as a signal. If you're working inside of a domain in the context of a team and a word means more than one thing, you got a problem. And so then very quickly the idea became, how do we separate out those concerns? Where is it appropriate for it to be at? Because all 3 of those are actually product-specific kind of issues that we need to talk about where they fit. So we can use ubiquitous language as a signal. So again, we're using this idea of product context, visualizing things out to reduce the cognitive load, to see the relationships, and reduce coupling. That group, and you'll see a little bit more of their work here in a second, 14 teams down to 10 teams. Didn't, again, happen overnight. As the first team was able to move towards a decoupled architecture. Now, this is a team, I kid you not, the first week I was with them, they spent 5 minutes coding the whole week to ship 1 bug fix. Because it was that hard to build, that hard to test, and that hard to deploy. 5 minutes out of a week. And of course, people are saying, why are my engineers so slow? We got to get more teams. This is not a team problem. The problem was all this coupling. This team, as soon as they got into their new architecture and they were able to start refactoring kind of little piece by piece, they actually only had 1 of those bubbles, but they said, our work is so easy now, we can actually take on 2. That is beautiful. Now, of course, we don't want to kind of have that. We had to talk about techniques to make sure they didn't mange them together. But the fact that their work became easy, the cognitive load was so low, it was easy to build and test and deploy, they said we can take on more work. It didn't take forever, it just took a little bit of time. All right, so we get those macro level views, kind of how do teams fit in. Now, if you're not multi-teams, then I would tell you I would do the same technique just to find proper modularity related to your architecture. If you get, so once we get there, now we talk about local decisions. How does my team, my area contribute? So we have this idea for the event storming, looking for our domains, and we get into C4 modeling. Fans of C4? A couple? Take a bit of time? All right. I won't go through it too much here for you, but the idea just being the appropriate view of the architecture at the appropriate time. It always starts with the context. So I'll show you kind of what the 4 C's mean. I'll show you some of the stuff that I can show you from the company to get an idea about it. And we'll talk about actually how it made sense. C4 model has 4 C's, right? Kind of mind-blowing there. The first C, of course, is context, right? How is the product being used? The top dark navy-ish icon there being a persona. This is our customer. This is our user base interacting with our system. The gray ones are supporting systems. The blue one ends up being the idea of the system we want to drill in upon. What I love about this is it's using the language of the customer. So if you see the dotted lines, the first one says the personal banking customer views account balances and makes payments using the system, right? And so you have this kind of active customer-centric language around these models. And then we can drill into them for further detail. Now, here's what it looked like in practice for us, right? So you can't really kind of see it at all here. But you can see, there's a kind of a target up there in the upper left corner trying to get this thing done by the 31st. Now, what I think is interesting also about this, it turns out you can't re-architect and just tell your companies, hey, you know what, we're not going to do anything for a couple years. You actually have to have a plan of how to iterate through it. And so we had to talk about iterative architectural changes. This is the first target. You can see the persona up there kind of on the top, the main team in the blue box there, and some supporting systems all around. What it was valuable for the team is they found out that they were proxying data for a lot of other teams. So you can see in the upper right there, one of the left orangish sticky talks about the proxied data. Data that they didn't need for their product in their context, but other people depended upon them to have, right? Because again, the system was mangled together. And you can't just say, you're not going to get it from me anymore. You had to kind of give the other teams a pathway. So we were very visual in here and socialized this design. We said we're proxying this data, but it's going to be going away. Here's the fields that are going to go away. That's at a C1 level, kind of product context, persona using our system, kind of macro level areas, talking about the systems we use. We then get into the second C, the second C in the C4 model being containers, not Docker, right? Think components, kind of think modules, think something along those lines. In this organization that I was in, the second C became teams. It was teams, kind of boundaries, kind of context. So now what we could do is we had this first C, kind of macro level, customers using our product. All of our teams contribute to this main product, supporting systems. If we drill into it, we could see here's the teams inside of our product. Now, what I like about this is, well, it looks better in the next one, which you actually can't even read. So inside here, you could see the teams that go together to make the product, and what they provide to each other in the language of the customer. Customers trying to get account balances, use the web application. Web application provides an interface to get the data from this place, which provides a read-only access, et cetera, et cetera. So you get this kind of language of the customer, high level, kind of drilling down more fidelity. Again, this is the example from the group that I was with. They had their future state part 1 and part 2. Right? This is kind of like when they're proxying data and when they're not proxying data. Now, the reason why there isn't as many blue boxes in here is the blue box up there in the upper left was just this one teams, and then we didn't colorize it to show the other teams, but you can kind of see some kind of dotted lines around a bunch of things that talk about other teams. That was going to be the first pass of the next architecture, but this was where they were going, kind of the event-driven, right, type of architecture. So showing the iterative nature of the architecture still in the same context of the product. And you can see kind of down here, these gray boxes became the other teams and how they were going to communicate with other areas. Once we got down across the teams, now it becomes, we have this context of the customers using our product. We have this context of how our teams work together to come together to solve a product for a customer. Now it becomes, what do we provide as a team that provides access to other teams that serves the product, right? So that at C3 level became the components of the teams, the services they provided. To give you an example of why this was interesting, if a person wants to open an account currently, they can't open an account on their own. They have to go into an office and somebody has to do it for them. Now, the person doing it for them wants to know when he can get the check, right? And so In the new system, in the new architecture, kind of event-driven, everything's asynchronous. The person comes in, and we start firing off events to get the documents generated, to get the bank information going, to get the account created, and all these events are happening. The person trying to get the account open doesn't care about any of those. They just care about when is it open. Now, the team that owns this interface that says when it's kind of in a good state has a local decision to make in the product. They can choose push notifications, right? They can say, this person loves my product so much, they want to be on it all day, right? That's what all your customers have, right? All of your customers want to be on your web app all day. So they can make that decision, and they could say, we're going to have WebSockets and push information to the browser all the time. Or they could say, we know our customer, and they're busy, and they don't want to sit in front of their computer all day, but they want to be notified as soon as possible when this is done. And so now, instead of worrying about WebSockets and all of this, we can say, how about we just send them an email? That's pretty easy. So now the team can make a localized decision because they have the context of the product. They know if any other teams are expecting this information from them, is the decision localized or not? And if it is, they can make a decision appropriate inside their context. So that's a C3 level. We're talking about services and what we provide. This is what this team ended up coming up with inside of their space, right? So kind of very simple stuff. There's a message bus, and they're responding to events, creating a local read-only view of the data, and then as the information becomes available, notifying the customers. By doing this 14 teams becoming 10 teams, they could have a common C1. Right? Because it's one product. Now, when we got to the final C1 across 10 teams, there wasn't just one persona like there is here. There was actually 4 or 5 personas with 4 or 5 different experiences. But we could see how the language that they would use, interacting with the system. We could drill into the teams, and we could see from a team perspective, how did the teams solve the needs of the customer in the language of the customer. And then we could drill into the teams themselves and talk about the services they provide and how it goes to serve the needs of other teams. The last thing I would tell you about having done this with the groups is security is kind of important, especially in a financial world. By having this kind of perspective, you have better security conversations. Because one is now security has context of how the services are being used, and they can talk about what information should be there and shouldn't be there. But also we can talk about what information we shouldn't even be providing as a team. This organization, because of the way it kind of grew up, they had this very, what I would offer up, dangerous model where all of the rules around accounts were externalized. So somebody could actually write a query through an API and query for the rules for accounts. That's not a good idea, right? And so we could fix that by seeing kind of the appropriate context inside there. And then last but not least, just for completion, in the C4 model, the fourth C being the code. Here's my dirty little secret for you all. I don't do this. I don't do this, and it's not because it's bad. If you want to do it, cool. What I'll tell you this is, if we do the C1 well and people have context and we get to good teams and the teams make sense and they have simple contexts and it's easy to understand, and then they have small services and small interfaces and just kind of everything is clean, this is trivial. And I get 90% of my value from C1 and 2 and 3, and I don't even worry about C4. So that's just me. If you need to do it, otherwise, it's cool. I heard in Europe you're all wonderful at testing, so this is more of a US problem. In the United States, all organizations say we have to have more automated testing, and they set ridiculous goals. What I'll tell you is a lot of teams struggle with automated testing because the architecture is bad. It's hard to test. It wasn't designed to be tested. Your mileage may vary. Having done the C4s with teams, we can have a simple conversation. Your unit tests are at the C4. right? Your integration tests are at C3. Your functional tests are at C2. Your regression at C1, right? It became that simple for teams. That was easy, and I saw teams make momentum that way. To get started, use a product context, right? Add ideas, drill down as you go. Use the language of your customers, and please socialize this. Yeah, look, do this iteratively because you're going to learn things as you go, just we talked about with Ward. There's a whole other space in this around data. Data gets wild, but I'll skip that for now. Last kind of thing to throw at you. So now we have this idea of macro level decisions, kind of where teams should be laid out. We have local decisions, kind of how does the product architecture affected by localized teams. This last idea around context mapping in the DDD space, talking about relationships. I bring up for one reason only. There's a couple different patterns for context mapping, right? So the idea being, how do we make sure we have the proper decoupling across teams? In our organization, not our organization, the organization I was with, this is what that first kind of teams look like. I bring this up because you can see things like the bubble on the far left around beneficiaries. It was a separate concept, unique on its own. So if we had a published language or an API, that was enough to kind of serve that need, right? And so anybody that needed information, we could have a REST API. Everybody's happy to find out the beneficiaries if they needed to generate documents, something like that. We had to use a different technique, the ACL, between the banks and the money in the accounts, because you want to be able to add banks at a faster rate than anything else, right? Like if you want to go to new countries or diversify your market, you need to add new banks and new protocols, and that needs to be separated. So we had to have a strategy to do that. The thing that I think was interesting, though, was between the funding and the trading, there was a necessary coupling. There was a necessary coupling because it turns out you need to have money to trade. And when you trade, people want to know how much money they have, right? There was a necessary coupling there. In this organization, and I know none of you would fall into this trap, but in this organization, the way the teams worked was every team had to follow the same process. Everybody is autonomous. Just make sure you follow the exact same process. Put everything in Jira. Make sure you put points on it, et cetera, et cetera. Once we got to this point where we could talk about appropriate decoupling, then we could actually have conversations around which type of process was appropriate for which teams and which teams needed to plan or actually work together. When you have 14 teams and the code's mangled together, you don't know what to do, so you make them all plan together. So they all get together, they tell each other stories, and then 2 days later it's all lies because the world changed. The last thing I'll tell you is when we identified this as a necessary coupling between teams, we shouldn't confuse communication with collaboration. Communication is we're just talking. We get together, I tell you I'm on ticket 1973, you ignore me, and we go on. Collaboration is we build together. We build together. If there's a necessary coupling because the product needs it, then we should build together. We shouldn't just talk at each other. We need to build together. And so we use this to figure out appropriate ways of teams to work together. So there you go. As an architect, our job is never stick figures and boxes. I used to do the UML stuff, right? Where like there's a stick figure and a bunch of boxes, and then it didn't make any sense to anybody. So maybe that joke's not as good as I thought it was. But I think our job is to provide modeling based in context, product context that's rich, that helps people reason about the stuff that they're working on, give it meaning, and make it easy for them to write less code. I think that's what we want to do as architects. Take a world of possibilities. You all can build anything. Use proper product things to deliver maneuverable, simple systems that bring joy. I think the coolest thing that you all could do is, if you want to talk about success as an architect, is when somebody comes to you like 4 years from now and they're like, that architecture you did makes my job easy. That's cool because everything makes sense. That would be cool. Nobody's going to come to you 4 years from now and say, "Oh man, that was so awesome that you chose Kubernetes." Like it's not. And maybe it will. It shouldn't. So there you go. There's some recaps for you. Use these techniques using product context, C4s. Uh, please remember Ward. Kind of refactoring our models. None of this is a one and done. This is a continuous evolution of modeling as we learn more. And then some books up there for you, right? The Weinberg book about thinking about how we solve problems. Christopher Alexander's books on architecture, which I think a bunch of them are just beautiful. The DDD books from Von Vernon, Eric Evans, and of course Paul Rayner's stuff on event storming. That's what I got. I think I'm on time. What questions do you have before you eat and it smells wonderful? I talk too fast or too sarcastic? What's up? Yes. Yes. How did we cope with the product being live? That is a wonderful question, and everybody assumed it would go down. So, without getting into too much detail, like the way this product works, for all of those account types, there was actually, let's say, 100 different types of accounts, and they all had different kind of usage patterns. And so instead of trying to say, like, first thing we're going to do is move the way the accounts work, and then we're going to move the way the documents work, we said we're going to take one account type out of the 100. And we're going to do the least amount of code that kind of starts spanning across these teams to get the communication protocols built up. And then we had just a simple, they're both going to run in parallel at the same time. And so we're going to be able to open up 99 accounts the old way, one account a new way, but if we had the circuit breakers, we could fall back to the old code if we had to. That allowed us to do this kind of like this simple thread across the systems, build up patterns, socialize design, and not get too lost in the complexity of it. It took us, I want to say, about 2 months to do the first account. Second account took us about 2 weeks, and then it became like really kind of quick and fast to start adding more and more accounts. But to your point, like you can't just stop it and say, we're 6 months from now, cross our fingers. We did it very small and piecewise. Yeah, good question. Yeah, please. Who was designing the domains? The we? Yeah, it was. It, yeah, it was product ownership, along with some architects. Now they would do the first pass at it, and then the teams would get involved and ask questions and add some fidelity. But it was predominantly product ownership